Assalamualaikum everyone. Today we're going to continue our lecture with lithography. So this process basically similar to the conventional printing previously, which means litho means print, graphy means writing. For semiconductor, type of lithography can be classified into four, which are optical lithography, X-ray lithography, electron beam lithography, and ion beam lithography. So today we are going to go for optical lithography first. Optical lithography refers to the lithographic process where visible or ultraviolet light is used to form pattern on the photoresist through printing. So printing in the process of projecting the image of the pattern onto the wafer surface using a light source and photomask. The most used optical lithography is photolithography. So we're going to cover this again so that you can recall the process of photolithography, what we have covered in the IC fabrication previously. So for photolithography, it uses light source for irradiation to expose coating of photoresist on the surface of the wafer. So the most common light is UV light. So this is due to the short wavelength. So a mask containing the required geometry pattern for each layer separate the light source from the wafer, and only the portion of the photoresist not blocked by the mask are exposed. So this one it depends on the type of the resist also. So this we're going to look again later. Let us recall the photolithographic step. Okay, so photolithographic steps start with the wafer cleaning and oxidation. After that, photoresist application will take place before going through the soft baking. After that, the mask alignment and exposure will take place before the development of the IC will start, and then going into the hard baking, and then goes for etching, and finally we strap the resist in order to get the final product. For oxide growth on the Si wafer, so insulating dilated layer, which is silicon oxide, is first grown on the Si wafer. So this layer is used to provide insulation between the conducting layer and also between the conducting layer and the underlying Si wafer substrate. So as a supplementary masking material during fabrication operation in order to protect the Si surface. Okay, so the oxide growth can be performed in two methods. One is thermal oxidation and another one is CVD. Thermal oxidation is performed at atmospheric pressure with the temperature range from 750 to 1150 degrees Celsius. So in this process, oxygen and hydrogen gases used to form water vapor, where if you can see the red color in the picture is the Si wafer that has been arranged in the tray, and then there will be gases, oxygen and hydrogen will go into the system, okay, into the chamber where the Si will be exposed to the oxygen to form the SiO2, which is the silicon oxide layer. So thickness of the oxide layer will stop further chemical reaction, and the layer will be around 1000 atomic size. Okay, so for chemical vapor decomposition, CVD, usually it is employed if thicker dioxide insulation is required. So employed in between fabrication step when oxide layer is required to be grown. So the difference from CVD from the thermal oxidation is the Si is supplied from external source and instead of from the wafer itself. And then for reaction to form SiO2, there are additional SiH4 react with the oxygen at 400 degrees Celsius to 450 degrees Celsius, and then SiH4 react with the nitrogen at a temperature of 650 to 700 degrees Celsius, and then SiH4 um, react with the carbon dioxide plus the hydrogen at temperature 850 to 950 degrees Celsius. After that, the photolithography process will start with the coating of the photoresist. The green part is the photoresist, okay, and then after that it will be exposed to the UV light, and then it will develop into the circuit that we want to create, and then etching process will take place, and after that the resist will be stripped to expose the final product. So important factors in photolithography involve photolithographic mask, photoresist, and exposure or irradiation process. Photolithographic mask is a flat plate of transparent glass which a thin film or of an opaque substance is deposited in the certain area to form the desired pattern. Okay, so this example, the picture shows the example of the photolithographic mask. So the thickness of this glass plate is around 2 mm, while deposit film is only a few micrometer thickness. So the mask itself is fabricated through lithography process, and the pattern is based on the circuit design. So this one, the circuit design usually will be designed by the circuit designer using the CAD system before the photolithographic process take place. So this one you already see in the videos previously in the process of fabrication and mask design. Okay. So, photoresist is an organic polymer which is very sensitive to the light radiation in certain wavelength range. So, the sensitivity will cause the increase of or decrease in solubility of the polymer to certain chemical. So, photoresist usually very sensitive to the UV light. Typically, what we use in the semiconductor processing. So, UV light has short wavelength compared to the normal light, the visible light. Okay, so this one will permit sharper imaging of the microscopic detail on the wafer surface. So it also permit fabrication at low light level outside the UV band. Now let's see the process how the photoresist is applied. For the first one, wafer is placed on the vacuum chuck, okay, and then liquid photoresist will fed into the center of the wafer, like shown in the picture, and then wafer spin to spread the liquid photoresist, and due to this spinning, a uniform thickness will be achieved. Okay, so the speed usually used is around 3000 to 6000 rpm within the time of 15 to 30 minutes, when the thickness will leave of the photoresist leave on the wafer is around 1 to 2 micrometer. So if you can remember the type of the photoresist, we have positive photoresist and negative photoresist. So positive photoresist with the exposure of the UV light will change the chemical structure in it, and it become more soluble. And for the negative photoresist, the exposure of UV light will cause the negative resist to become polymerized, so it will become more difficult to dissolve. So let's see the negative and positive photoresist effect. So if you can see on the left, it is the negative photoresist. When the photoresist is exposed, it will become insoluble. Okay, so it will be hardened. So then what happen is when the UV light go through this part, and then it will be etched. Okay, so then the pattern that leave in the on the wafer is like this. Okay, so positive photoresist, it will expose photoresist and become soluble. So once it's soluble, so what happen is this one they will create the layer on the parts like this. Okay, in exposure and irradiation, there are three types of printing. The first one is contact printing, proximity printing, and projection printing. So for contact printing, the mask is pressed against the resist coating during the exposure. So the advantage is the high resolution of the pattern onto the wafer surface, but the disadvantage will be the physical contact with the layer will gradually wear the mask. Okay, so for proximity printing, mask is separated from the resist coating with the distance of 10 to 25 micrometer. It will eliminate the mask wear, but image resolution will slightly reduce. For projection printing, high quality lens or mirror system is project the image through the mask onto the wafer. So this one is a preferred technique because of the non-contact and it is optical projection. So it can also obtain high resolution. Now let us see the comparison between the contact printing, proximity printing and projection printing in terms of the diagram. So if you can see in the picture, this is the mask. Okay, so this mask is contact with the resist. So this one, there is no space between the resist and also the mask. So for the proximity printing, there is a certain area that separate between the mask and the resist. And for this one, the last one is projection printing. All the pattern is projected through the lens. Okay, so that's why there is a distance, a big distance between the lens and the resist. Okay, so this one, the mask also can be saved. In the same time, the projection of the light towards the wafer will get a good resolution. After the printing process, there will be a etch back process. We can recall again. So the thin film of desired material is added on the substrate, and then we apply the photoresist, and we are going to etch the first film using the resist as the mask, and photoresist will be removed to get the pattern thin film over the substrate. So the term used for the stripping the photoresist is called lift off. So a layer of photoresist is deposited over the top of the substrate. So the resist is the pattern also. So after the film of desired material is deposited over the pattern of the photoresist, it will swell the photoresist with the solvent and remove the photoresist and then get the pattern thin film on the substrate. So before we finish the photolithography topic, so let's see the step again one by one. First, the wafer will go into the cleaning process and oxidation to get the silicon oxide pattern layer on the top, and then photoresist application will be applied before going into the soft baking, which is to harden a little bit the resist. Okay, before the mask alignment and exposure take place. After that, the development of the circuit will take place until everything is finished, and then hard baking will be applied before the etching process take place, and then after that the lift off or strip of the resist will finish the process of photolithographic step. So here are some video links, so hope you enjoy. So that's the end of photolithography. See you in the next class. Assalamualaikum.